Hi, this is Gerald Kaipan, and I'm doing the AP Physics 1 algorithm project for problem number 5. So for this problem, we will use the force toolkit, and if you need the steps, they're shown here. 3 identical blocks each take a different path from a height h to the ground. Block A is released from rest and falls vertically. Block B is released from rest and slides down a frictionless incline. Block C is projected horizontally with an initial speed of v. Which block takes the longest time to reach the ground? So again, we use the force toolkit. So for step 1, identify the system being accelerated. We would say that there are three separate systems, block A, B, and C, that are being accelerated because each block is independent of each other. Step 2, define a coordinate plane, which is that up and right are positive. Step 3, we would show a motion map and also a force diagram for the system. So we'll do it for each separate block. For block A, there's only a force of gravity. So in the motion map, there's a constant acceleration going downward. For block B, first off, it's on an incline, so this axis is tilted. Anyways, there is a normal force that's applied by the surface, and then there's a force of gravity that's at an angle, again, because it's on an incline. Block C, there is also only the force of gravity going downward, so there is a constant downward acceleration. However, for block C, there is also a horizontal movement, horizontal velocity, and that's constant. And because it's constant, there's no acceleration. It ultimately doesn't affect the vertical acceleration. Step 4, explicitly write F equals ma, Newton's second law. For this problem, we would use acceleration equals force divided by mass, which I believe is the way that it is expressed on the equation sheet. Step 5, we would substitute any forces for the system. So we'd do it for each separate block. So for block A, acceleration would equal the negative force of gravity divided by the mass. Block B, acceleration equals the normal force minus the force of gravity divided by the mass. And block C, acceleration equals the force of gravity divided by m. For step 6, we would substitute any numerical values and basically plug and chug and to get answers for these. However, there are no numerical values, but we still can conceptually derive how this would work for each system. So for block A, we'd say acceleration equals mass times gravity, the force of gravity, divided by the mass, and we get acceleration equals negative g, negative gravity, which is basically just gravity acting downward, which it does normally in Earth. For block C, acceleration equals, again, mass times gravity divided by mass. Then we cancel out the masses, get acceleration equals negative gravity. For block B, I mentioned earlier that it was on an incline. So again, this is a tilted axis. And because it's tilted, this force of gravity isn't completely horizontal or vertical. It's at an angle like this. So what we would do is we would create a component diagram. I believe that's the name of it. So what we can do is if we have an angle here, we could use cosine and find the vertical component, and then use sine and find the horizontal component, and basically multiply that by the force of gravity, mg. Now, because this block isn't being pushed off from the incline or pushed into the incline, we can assume that this vertical component of gravity would cancel out with the normal force. So that leaves us with mg sine theta, the horizontal force of gravity. So what we can do is we can resubstitute this back into the equation. Acceleration equals mg sine theta divided by the mass. These two masses would cancel, and we get acceleration equals the negative gravity times sine theta. Now this sine theta basically means that the force of gravity on an incline is only a fraction of the actual force of gravity. So this this acceleration is only a fraction of what these two values would be, depending on the angle. And because of this, we can say that block B will take the longest time to reach the ground. For blocks A and C, there's no air resistance, so it is a straight free fall downwards for block A. For block C, it is the same because this horizontal initial velocity doesn't affect the vertical motion of the block. And again, just like we proved in the last slide, this block B is being affected by only a fractional portion of gravity because gravity can't completely act downwards on the block. So therefore, the block that would take the longest time to reach the ground would be block B.